Welcome to NHM Live. I'm Alison, I'm your host today. Now, wherever you're watching from, whatever platform you're watching on, remember we are live, so please don't be shy. If you have any questions for any of our speakers, post those in the comments. If you want to tell us where you're watching from or just say hi, we would love to hear from you. And we have another packed show for you today. We're going to be taking you behind the scenes. We're going to be revealing this month's mystery specimen. We're going to be taking some very dubious dating advice from the animal kingdom and also catching up with the latest news. But first, if you follow our show, you know that we love to take you behind the scenes here at the museum. And this month, we caught up with curator of fossil invertebrates, Zoe Hughes. Let's take a look.
Hi, I'm Zoe and I am curator of brachiopods and fossil cephalopods here at the Natural History Museum. I would like to show you some of my favourite specimens today. So, this specimen, while it might not look like much, this is really amazing because it was found by Charles Darwin, and as far as we're aware, it's the first ammonite known to science from South America. This is a fossil brachiopod. Brachiopods are a type of marine invertebrate with two shells that were thought to be like bivalves for a really long time, but are actually something completely different. Now, this brachiopod's really cool because it's the biggest type of brachiopod that we've seen on Earth since the Carboniferous period. It lived in a time when the atmospheric carbon dioxide was about what it is today at 400 parts per million. In the 17th century, there was a man called Thomas Davidson who started out as an artist but ended up working on brachiopods, and he wrote a series of amazing monographs that we still use all the time today. But one of the amazing things we have in this collection is a series of his notebooks, featuring letters to other brachiopod workers and also the original drawings that he made to get to all the illustrations. So, as you can see, I look after a wide variety of things, and that is just a small selection of the large collection that I'm responsible for here.
And Zoe joins us now in the studio. Zoe, thank you so much for coming down today.
You're quite welcome. Yeah.
And thank you for showing us around there as well.
I'm happy to have visitors. I like showing people the collections.
I love coming up to your collection space. There's always so many fascinating things to see. And I have to confess though, a little bit embarrassing, I had never heard of a brachiopod before I met you.
To be honest, that doesn't surprise me because no one has heard of them. They're really niche sort of group that, while they fossilise quite commonly, a lot of people just aren't really aware of their existence. So that is something I'm definitely trying to work on changing.
And they've been around for a really long time, haven't they?
Yeah, so they appear in the fossil record about 500 million years ago. So obviously quite a long time. And what's interesting is we've got recent specimens, so specimens that were collected in the last couple of hundred years, that actually look quite a lot like specimens we've got that are about 500 million years old. So they don't really kind of seem to change too much in their appearance.
So an amazing success story.
Yeah, definitely.
Brilliant. Now, it's not the brachiopods, unfortunately, we're going to focus on today. You also look after our fossil cephalopods. Now, we saw lots of ammonites in that video there, but there's one aspect of our collection we didn't see. We do actually have some fossil octopuses, don't we? Yes,
so we have 4 fossil octopuses in the collection, so we don't have a lot of them. I look after about 9,000 drawers, and the fossil octopuses only take up about 5, so you can sort of see that they're quite rare. This is actually one of the older ones that was discovered, so this was part of the collections of the Geological Museum that used to be next door and now forms the BGS, but they gave us all their foreign material when they became the British Geological Survey because it didn't fall into their remit, and this is a specimen from Lebanon that we got from them.
So I'm guessing they don't fossilise that easily. What sorts of conditions do you need to get a soft-bodied fossil like this?
So you need fine sediment that falls quite rapidly on the decomposing animal. You need an anoxic environment, so no oxygen, so it won't decompose, because in order to get the tissues to preserve, you need them not to decompose or be eaten by anything in the area, so you need to kind of cover them up quite quickly. It's a bit complicated, but that's basically the gist.
And where are our fossils found, and do we know how old they are?
So the majority of the fossil octopuses known around the world are all found, or pretty much apart from 2, found in Lebanon, and they're about 95 million years old.
And we've got another brilliant example there. What amazes me looking at some of these images, obviously we can't bring them into the studio. They're very
that one's really quite big.
rare and delicate, and in some cases large. What amazes me is how well preserved some of them are. What sorts of features can we actually make out in these specimens?
On that specimen, you can see you've got the ink sac there. You can also see various bits of their arms. They are arms, not tentacles.
Yes.
A lot of people don't know that. Another specimen we've got, you can actually see the suckers really, really well. And it's also got eyes, which is just absolutely super.
Amazing.
Yeah.
Wow. And I've hoped the ink, we've got the suckers there.
So this is, so you can see the impression on the suckers, and this is the actual phosphatized octopus. So when it fossilises, the phosphates from the rock around fossilise into the actual tissues of the octopus.
And the ink you pointed out there, that was very dark in colour. Is that? Can we tell what the ink was actually made up of?
Yes, so a researcher in Bristol actually did some chemical analysis of that ink. It's dark because it's got a pigment called melanin in it, and those melanins are actually quite similar to modern melanins in recent sort of cephalopods that are swimming around today, which is quite amazing.
Yeah, not changed very much at all.
Not changed that much at all.
All that time. That is amazing. So what sorts of research are we doing with our fossil octopuses? What can we learn from these fossils?
So a lot of what we can learn about what was going on in the oceans at the time, where octopuses lived. However, there are some issues with that because we found so many from Lebanon, but nowhere else. We don't really know what else was going on in the world of octopuses at other times in other places because they do fossilise so rarely. But we can get an idea of like their evolutionary history and sort of what features they had, and yeah, they're all quite amazing, really.
Lots more work to do, but
definitely
fascinating to see, and so lucky to have these in our collection.
Very lucky. They're really beautiful specimens.
Well, Zoe, stick with us.
Okay.
So Zoe will stay with us for the rest of the show. So if you have any questions about fossil octopuses, about cephalopods generally, post those to us and we'll answer them live. Now, in a moment, we'll catch up with the latest science news. But first, if you've been following our social media feed, you'll see that we've been teasing you with yet another mystery specimen. But what could it be? I'll give you a clue. This one was found not too far from where we're sitting. Let's take a look. So there you have it, quite a tricky one this time, I think. Zoe, any ideas what it might be?
I'm not sure, to be honest. Maybe a bit of wood?
Yeah,
don't know.
Could be. Well, post your guesses and we'll reveal the answer at the end of the show. But now, let's jump over to Josh in the NHM Live newsroom for the latest science news.
This month saw the publication of a major new study looking into the state of the world's insect populations. Whilst that study did have some limitations, it has brought into sharp focus a raft of serious concerns as the insect populations around the world plummet. This will have significant impacts not only on the environment and wildlife, but may also threaten our own survival as it affects food security and pest management. New research is also revealing how Darwin's finches don't tell the full story when it comes to avian evolution. Rewriting how we think ecosystems influence their evolution, the researchers found that a bird's diet is not necessarily the primary driver to the shape of their skull. Instead, it is more likely that there are many other ecological factors also in play here. Finally, we welcome a new member to the tyrannosaur family. Joining the more ferocious Tyrannosaurus rex is a new species of much smaller dinosaur called Morus intrepidus. Weighing in at just 76 kilos, this tiny dinosaur helps narrow a 70 million year gap in the fossil record and helping us explain how the tyrant lizards came to rise to dominance during the Cretaceous. Now, back to the studio with Alison.
Thank you very much, Josh. Now, there was one recent news story that we've been keeping quite a close eye on here at NHM Live, and that's China's recent lunar landing, their Chang'e 4 mission. Now, to delve a little bit deeper into this story, I'm joined by Natasha Almeida, our curator of meteorites. Natasha, thank you so much for coming down today.
Thanks for having me.
Now, what is it that's so significant about these China missions?
Yeah, so this is fantastic. Chang'e 4 is actually the first time that we've landed on the far side of the moon. So all of the missions so far have actually been landing on the near side. That's where the Apollo missions went and various other rovers and landers. This is the first time we've actually touched down on the far side of the moon. It's really exciting.
Which is very amazing.
The other cool thing about it is it's inside the South Pole Aitken Basin, which is basically it's the largest impact crater that we're aware of in the whole solar system. It's 2,500 kilometers in diameter, right? And the rover's actually landed inside there. Because it's so large, it actually would have excavated some of the interior of the moon. So it'll give us an opportunity to study some of the rocks from inside, which can help us understand its structure and composition, and also a bit about its origin as well.
It's exciting stuff. Now, we haven't really been to the far side of the moon, but we do know a bit about what it looks like, don't we?
Yes, we've known actually for a very long time what the far side of the moon, also known as dark side, not dark all the time, but we can come to that later. So we know what it looks like because in 1959, the Lunar 3 mission, which was a Russian orbiter, it actually went, to the other side and took lots of images. It was a little bit grainy, but it gave us an idea of what it looked like. Now this is actually from the Lunar Reconnaissance Orbiter, which is a mission that's still active right now. And it's been taking pictures since 2009, I think it started. And some of the images it has is even down to resolution of 50 centimetres a pixel.
That's amazing.
It's crazy, yeah, really impressive.
Oh. And the near and far side, they do look quite different, don't they? Do we know why?
They do. Actually, it's quite difficult to know why. So there are some theories as to why they may look so different, but it's questioned just since we first looked at it. Why is it? So this is a good example of the two sides. So the far side, it looks much more densely cratered, which indicates it's a much older surface. We know that the crust is thicker on this side. One of the starkest differences, I think, is the mare. So these are the black areas here. We call them mare, which comes from seas, because when they first looked at it, they thought they were actually oceans. But they're actually seas of basalt, so they're from volcanism occurring on the early moon. Now on the near side, we're used to seeing them, right? The big black patches when you look at it. They account for about 30% of the surface area. On the far side, it's only 1%. Wow. So there's lots for us to understand, but we, would love to go and bring back some samples so we can study them.
And what are the key aims of the Chang'e 4 mission? Will they bring back samples?
So Chang'e 4 unfortunately isn't going to bring back samples. It's just a rover that's going to be studying them in situ, we call it. So they're looking at the chemical composition of the rocks and the soils, the lunar regolith, we call it. And it can measure the temperature. It also has something called a ground penetrating radar. So it can look at what the structure of the subsurface underneath them is. They're also doing a few other things. It's not my area of expertise, but for example, some radio astronomy. So from the far side, you don't experience the radio pollution that's released from Earth. So it's a good place to do that, and looking at the solar corona and stuff like that. So it's an interesting mission. It's also sort of on the way towards, it's a roadmap towards Chang'e 5 and 6, which are proposed to actually be sample return missions to the moon. So super
brilliant.
excited for that.
Now we do of course we have pieces of the moon from the Apollo mission. We have lunar samples from that particular mission, and we actually have some of those at the museum, don't we?
We do. There's two. So this is one which is called the Goodwill rock. This is the only Apollo rock that actually belongs to the UK people, and we look after it here on their behalf. You can see it in the Treasures Gallery. It's fantastic. And there's also another piece from Apollo 16, which is on display in the Earth Hall, but that's on long-term loan. So all Apollo rocks belong to the United States. They're looked after at Johnson Space Center. So that's the Apollo 16 one that you can go and see. But what we do have, which is super special, and I'm very privileged to look after them, are some lunar meteorites. So there's 8 different lunar meteorites represented in our collection.
That's amazing, and you've actually brought one along with you,
I
haven't you?
have,
Can we take a look? I'm not allowed to touch this, unfortunately.
You can zoom in on this a little bit.
Brilliant.
Yeah, so we handle it with gloves because we don't want to contaminate the sample. This is called NWA 11444. Yep, very catchy. Northwest Africa, so it was actually found in the Sahara Desert, and we acquired it last year. It's 147 grams, that piece there. But yes, it's a very nice specimen. So over 100 kilos of this meteorite has actually been found. So there's quite a lot of it.
Pretty sizable chunk.
How
That's
big would that have
fantastic.
been?
So it's not in one big piece.
Oh, okay.
So it's actually in lots of smaller pieces, because as it was coming through the atmosphere, it broke into different bits, and then it's fallen in what we call a strewn field. So there's a big area where you find the same rocks.
Wow.
How do we know a meteorite is definitely from the moon?
Yeah, good question. So, I mean, one of the reasons is that it's very old, so somewhere 3.8 to 4.5 billion years. It's very old compared to Earth rocks, but actually quite young compared to meteorites, which are most of them are 4.5 billion years old. But scientists actually look at the minerals that are inside these specimens, and they look at the elemental composition of that. So they look at how much iron there is, or magnesium, or silicon, and you can use these as fingerprints for whereabouts in the solar system these things come from. And then, of course, when Apollo landed in the 60s, and then they brought back 382 kilograms, I think, over all those 6 missions. And so it's great we have direct reference that we can compare it to. So we're definitely sure they're from the moon.
So what sorts of research are we doing here at the museum with our lunar samples?
So there's so many different questions that we still have to answer about the moon, and that's why it's really exciting, I think. And there's lots of different things that we've been working on, CT scanning, various bits and pieces. But one of my favourite ones is we're looking at the origin of water on the moon. So it stands to reason that the water on the Earth and the moon came from the same place. We're the same system, we were hit by the same things. Whereas the water on the Earth is so processed, right? We've got geology, we've got living things, we've got atmospheres. Biosphere, that's probably the technical word for it. Yeah, you can tell I'm a geologist. So they're constantly processing our water, and it's kind of overprinting that original signature. Whereas not a lot has happened on the moon for like 4.5 billion years. So it's a kind of better record. The water is cleaner in some ways. And so Professor Sarah Russell, who's one of the leaders of our group here, she's been working on a project to look at trapped water and some minerals in meteorites and Apollo rocks, and actually comparing them with what we know it's like from things like carbonaceous chondrites, which are a type of meteorite that come from the asteroid belt. And they're actually able to show that the majority of the water in our Earth-Moon system came from water-rich asteroids.
Wow. Didn't know that.
No,
It's
it's
amazing.
pretty cool, and it's a nice link to some missions that are at the moment OSIRIS-REx and Hayabusa 2. We don't have time to cover them all, but it's worth Googling them if you have time, which are actually sample return missions to these asteroids, and they're going to be bringing pieces back, which hopefully we'll be studying a bit of at the
Brilliant.
museum.
Amazing.
Brilliant, and we'll have to bring you back in to
Do
tell
another
us all
one,
about
yeah.
that.
Absolutely.
Now we do have some questions from online. Question for both of you actually. After years of working in curation, do you still get excited when you open a drawer and look at a specimen? I mean,
Definitely.
yeah. But you can tell. You can tell
Yeah.
you do.
Yeah, normally you can't get us to shut up, I think, is probably
Yeah,
the
it's
case,
probably
isn't
the
it?
problem.
There is never a moment when holding a piece of the moon or Mars or 4.5
Something Darwin
billion-year-old
found.
rock. Yeah, something
Yeah.
Darwin found. We even have a tektite that was given to Darwin in the meteorite collection, yeah.
Oh, wow. Didn't
There
know
you
that.
go.
Wow.
Yeah.
Which does bring us on nicely to another question from one of our viewers, for both of you again. Would Zoe and Natasha ever get the chance to work together, even though you work in very different fields?
I think the closest we've come to that is working at the Lyme Regis Fossil Festival together.
Oh, yeah, that's true. We
Yeah.
do lots of outreach at the same time.
Yeah.
But
there's
not
no
so
space
many
for
brachiopods in space.
No, not so
sadly.
many. Or
I guess the
octopuses.
only link really is that there are extinctions caused by asteroid
Of
impact.
course. Yeah.
So there you
That's
go.
Yeah, that's probably the only link between us, really.
My stuff killed your stuff. Is that the link?
Yeah, pretty much.
Great.
They should be enemies.
Awesome. Good question.
Well, thank you both for chatting today. Stay where you are. Thank you very much for those questions. Keep them coming. Natasha and Zoe will stay for the rest of the show. But now, the 14th of Feb was, of course, Valentine's Day. And thoughts at NHM Live, well, they inevitably turned to romance. We were looking for some inspiration, some dating inspiration, so we asked our host Eddie to explore some of the more unusual courtship rituals in the animal kingdom. It's fair to say he took his brief quite literally. See what you make of this.
Hello sunshine, hello sky. Hello white clouds floating by. Hello happy, hello free. Hello you and hello me.
Well, you saw him strutting his stuff there, and Eddie joins us now on the sofa. I wish our viewers could have seen Nat and Zoe's reactions to those films. Amazing.
Some quite interesting ones there. Right?
Yeah, Eddie, where to begin? Probably what and why would be a good start. We saw three different behaviours there, three different rituals. So what were you imitating and why?
So the first one, bit of a strange one, essentially running around and just stealing things from people in the offices. It sounds a bit strange. That is the bowerbirds. Now the bowerbirds, they're quite well known. They have this amazing behavioural pattern where they build, as you can see here, these incredible structures to impress the females. The males will go around collecting these different things, and you can see they love brightly coloured things. They love finding sort of shiny, brightly coloured objects. Those are actually little bits of plastic. It's really common to find them finding these bits of plastic and adding them in to impress the female. So it's an odd behaviour. And what's especially weird is those bowers, those little shapes that they're building. They're not nests. They are literally just for that mating ritual. And then at the end, I was doing that slightly strange
I wondered
reveal.
what that was.
It's not quite as impressive as the bowerbird or emit. The bowerbird actually do a little dance with the female in this structure to impress them. I'm not able to do it. They actually dilate their pupils. Just sort of differently, independently from one another. I can't do that on cue, so that's probably why it didn't work.
It's incredibly elaborate, isn't it? Do we know why they choose the objects they do?
We're not really 100% sure. Different species seem to prefer slightly different things, and they're very fastidious in the way they organise them, but to us it seems to be almost entirely random.
And that second one, I think that was my favourite. What was going on with that balloon? I know we had some guesses online when we teased this. People thought you were a frigate bird. Is that right?
The frigate bird, yes, has that amazing sort of red bladder on the front of its body. Unfortunately, I wasn't actually being I was being a mammal, specifically the hooded seal, which you can see here. And it inflates this enormous red bladder out of its nose. And they actually initially use it for fighting with the other males. They use it as sort of a show of dominance and strength. And then whichever male wins then gets to show off to the female with a big nose bladder. And if she thinks it's impressive enough, then they get to mate. So yeah,
That's my favourite.
Yeah.
it's a bit of an odd one.
And is the balloon just for mating?
Well, the one that they have in their nose is almost exclusively used for mating. They also have on top of their heads another inflatable hood that they actually use when they're swimming, and we believe they use it for acoustic sounding, either to confuse their prey or to actually confuse predators and give them a chance to escape. So quite multifunctional bladders on their bodies.
Well, our first two strategies didn't work quite so well for you, did they? But the last one, that was the winner. So what animal was that?
So that people may have got that one. It's quite a clever one. It's the amazing little jumping spiders. This one's actually a peacock spider, and you can tell because it has those wonderful bright colours on it. But they do this lovely little dance to essentially get the attention of the female spiders. They are these quite intricate dances, and it really is. Seeing the videos of it, it's kind of sad to see because sometimes the females just completely ignore them, and they really try their hardest, but unfortunately the females sometimes just don't bite.
And do we know what function the dance serves? Is it just to identify themselves?
Essentially, yeah. There's a lot of different jumping spiders, and they all look quite similar to one another. So unfortunately, what happens sometimes is the males will try and impress a female from a different species. Jumping spiders are also quite cannibalistic, so they don't want to get eaten by the female if she's of the wrong species. So they do this dance from afar just to make sure that the female is interested before getting up close.
Sensible.
Yeah, sensible move. It's a smart move.
But Eddie, you better hope that your date doesn't take her role too seriously.
No, lots of spiders actually will eat the male after they have mated as well. The male, once they pass their genetics on, they're kind of okay with it. But yeah,
It's hungry work.
It's hungry.
At least you've also got some content for any dating profiles now. I hope you've
Exactly.
inspired some people.
Yeah,
There we go.
it's always useful to have out there.
Animal Kingdom, far more elaborate and interesting dating rituals than our own. I think as humans, we need to step up a gear. But Eddie, thank you so much for doing that.
No
I'm now
worries.
wondering what else we can get him to do on camera. We'll see. But we saw Eddie's efforts there. But let's see now how the real experts do it as we reveal the secrets of spider dating.
Just like humans, male spiders have to woo, flirt and charm their way into a female's heart. The tiny male golden orb weaver gives his much larger mate a back rub to get her in the mood. Now this massage calms the female and makes her more receptive and less likely to eat her partner. Male nursery web spiders wrap up prey items in silk parcels which they present to the female as a gift. He can then mate with her while she unwraps and eats her present. But my favourite is used by jumping spiders. These tiny arachnids perform elaborate dances to impress potential partners. This dance allows the male to identify himself to the female from a safe distance.
So we had the lovely Jen Bacaloni there, and we can learn an awful lot from spiders. Now, Zoe, there are some quite weird mating strategies in the world of cephalopods, aren't there?
Yeah, so cuttlefish in particular are quite cool. So cuttlefish can change colour, and they can actually do it down the middle. So, actually this is quite perfect. Imagine I am a male cuttlefish, Eddie is a male cuttlefish. I could be sort of giving him the signal of, hey, there's nothing to see here, everything's cool. And then on this side of my body, I could be going, oh, hello, come mate with me to Natasha. You are the lady cuttlefish. And then sometimes they will, and other species, they will kind of gather, they will pretend to be a female cuttlefish, like small males, and then they get gathered underneath the big male, and then while they're under there, they mate with the females that the male has also collected. So they're quite sneaky.
Absolutely brilliant, and something else for Eddie to try, maybe.
I'll give that one a go next time.
Now, you both have really cool jobs in the museum. Have you ever used the fact that you work in a museum to impress a date?
Oh, I never thought about that.
I have to admit I have.
Excellent. Nice work, Zoe.
Yeah, no, not me.
Yeah, I have to admit that, yes, I have, I'm sorry.
Something to try, something
Yeah.
to try. Now, we are sadly almost out of time this episode, but we do just have time to reveal our mystery specimen. Now, we've had lots and lots of guesses online. This one proved to be quite a tricky one, quite a wide range of guesses. We had Geo on Facebook, who thought it might be a tree bark or a nut. Peter, who guessed it was bracket fungus. Quite a good guess. Andre on Twitter thought it might be some fossilised antler or bone. Our personal favourite came from Mike, who suggested it might be a chocolate brownie. But unfortunately...
Any of them in the collection?
It would be bad for the IPM and things in the
Yeah,
collection.
yeah.
Don't want
Most of
food
our
there.
collection is not quite so delicious, is it? But very, very fascinating. There were a few people that got close, though. Let's reveal what it was. So Amy and Leslie on Facebook and Twitter actually got closest. They thought it was a mammal tooth. It is in fact a fossil elephant tooth. It's from a straight-tusked elephant, the genus Paleoloxodon. And what's great about this specimen is that it was actually found when they were digging the grounds of this museum back in 1872. So even while we're building the museum, we're adding to our collection, which is absolutely brilliant. So this particular species of elephant would have been roaming during the Midland Lake Pleistocene. It would have looked quite similar to elephants today, but apparently much, much bigger, up to 4 metres tall. So quite an impressive thing to see. Bigger. Cool. But that is sadly all we've got time for today. Thank you so much for all of our guests. Brilliant to speak to all of you. Thank you all for all of your questions and your comments and your guesses. Remember to join us next time. We'll be streaming again live next month, so we hope to see you then.